Okay, this is notes number 11. This is part 2 of the linear programming notes, where we turn them into a word problem. And this can look really complicated because you've got to read your way through all of these wonderful words. But if you set up a little chart at the bottom like I've done here, it's really not that bad. Let's go ahead and start reading. Supreme Shipping Company can load its trucks with both rectangular and cylindrical containers. So at the top of my box, I've labeled them rectangular and cylindrical. It says a rectangular container has a volume of 100 and a weight of 200. A cylindrical container has a volume of 200 and a weight of 100. Let X denote the number of rectangular crates, which I've done, and Y denote the number of cylindrical containers. Each truck has room for at most 4,200 cubic feet of containers. At most means we can't have any more than that, so it's less than or equal to 4,200 for volume. And each truck can carry a maximum, so that's less than or equal to, of 4,800 pounds. Okay, this is X, so I can put an X next to it, and this is Y. And we're going to add these together, and we have our equation. We have two other restrictions that we need to write down. Things are not going to weigh negative amounts of money. We're not going to have negative number of rectangular containers. So we're going to do X is less than or equal or Y than 0 and Y is less than or equal to 0. That just means we're only going to graph the first quadrant. I'm going to go ahead and label my graph. We know X is rectangular, Y is cylindrical. And we're going to use our intercepts again to go ahead and graph these. So, to find the x-intercept, I cover up the y. 100x equals 4,200. So 4,200 divided by 100 is 42. Okay. Now, to find the y-intercept, I cover up x. 200y equals 4,200. So I'm going to divide 4,200 by 200, and I get 21. Notice I'm not being super accurate here because it really doesn't matter. Okay, this is less than, so I'm going to shade below. Okay, my next line is 200x plus 100y less than or equal to 4,800. So I'm going to cover up the y to get my x-intercept. 4,800 divided by 200 is 24. So that's going to be right about there. And then to find the y-intercept, 100y is less than or equal to 4,800. So y is 48. Go ahead and draw that line in. Again, don't need to be super accurate. Okay, that is also less than. So I'll be shading here. And we're looking for where the red and the brown overlap. And that is going to happen right here. Okay, so now we know our region, and we just have to find our vertices. So, my first vertex is right here. Zero, 0. My second vertex is 24, 0. I don't need to do the 42 because it isn't part of the shade. How am I going to find that intersection? Well, I'm going to go back up and do the matrix. I've already typed that into my calculator for you. So here's what I'm going to do. Alpha zoom 2 by 2, 100, 200, 200, 100, inverse times alpha zoom 2 by 1. You guys were really good at this on your test, so I'm expecting good things. Hit enter, and my intersection is 1812. Okay, my last intersection, I wouldn't use the 48 because that's not next to the yellow. My last intersection is 021. Now, what are we going to plug this into? I haven't written an income equation yet, but it says that it's $50 to ship a rectangular, so 50x, and $60 to ship a cylindrical, so 60y. And this time using I for income, but it really doesn't matter. We're trying to maximize, so we're looking for the biggest answer we can get. When we plug 0, 0, we get 0. When you plug in 24, 0, let's see, 50 times 24 is 1200. Okay. 18 times 50 plus 12 times 60 is 1620. And then 60 times 21 is 1260. Okay, so which one of those is our maximum? Okay, so let's answer the question. What combination of containers should Supreme Shipping use to maximize its income? Well, they should use 18 rectangular and 12 cylindrical. If they do that, they're going to maximize their income of $1,620. Okay. Now time to practice some on your own.